Hello everyone. In this video, I'm going to create a simple binary tree in C++. Okay, this is the environment that we are going to work with. Okay, so this is available as onlineutility.com, so you can easily visit and check it out. Check this out. This is an online compiler, or you can always work in any environment you want. If you want, you can install dev C++ or code blocks if you wish to install, or Visual Studio Code also. All might work, but I'm going to use this because this doesn't need any installation. Okay, you can directly go and access the site. Cache include first of all IO stream. All right, and I'm going to using namespace standard. I'm going to use the standard namespace. Before that, I have to include this library also, stdlib.h, in order to use that malloc function, dynamic memory allocation functions. All right, after that, what I have to do is I have to define the structure of the node. Okay, let me say struct node, and it's gonna be int data. What we have seen in the previous video. That's it. I'm not gonna do anything else other than that. Okay, I'll be trying to tell you how to link the nodes. That I will do definitely. Here, the structure and all remains the same, right? Okay. Because in the previous video, I haven't told you how to link the nodes. Okay, I told you how to create nodes, but let me tell you how to link the nodes. Okay, I guess I have given a gist of it, but let me explain it clearly here. All right, so this is going to be our structure. Okay, so first of all, let me open the main function. Let me call it int main. Okay, in C++ only this works, and return 0. Okay, you know about this. Then what I can do is, first of all, I have to follow the same syntax what I tried to explain in the next previous video. This one, right? Actually, this particular code. All right, this statement I'm gonna repeat it for a lot of nodes. All right. So let me say struct node. Let me call the nodes as n1, n2. All right, it will be very easy. So n1, I have to typecast it, and I have to call my malloc function. Okay, if you can't understand this, then please go back and watch that video and come back here. Okay, I have clearly explained that why I am using this, why I am using malloc, why I am using sizeof operator, everything in the previous video itself. I'm just going to implement, and I'm just going to tell you how to link the nodes actually. Okay, so sizeof struct node n2 equal to struct node. Okay, so I'm gonna copy the same, and I'm gonna do it for n2 also. So like that, let me create 6 nodes. Okay, let me create 6 nodes. Guys, if you're a competitive programmer, in most of the platforms you are not required to create the binary trees from the scratch. Okay, what you're going to do is they will create the binary tree for you. They will give you the pointer to the root of the binary tree. Okay, so they will be creating the binary tree because they are only going to give the input to the program. Okay, they will give you the pointer of this head node only, the root node. Okay, so they will create the binary tree by themselves. You just have to implement the algorithm for the problem which you are solving, right? Since we are gonna implement our own algorithms using this approach only. Okay, so what I'm trying to say here is we will try to implement a binary tree using C++ using this particular code, and we will use this code in order to solve all the problems in trees. Okay, in order to solve all the problems in trees, we will apply this code as an input. Okay, right? So I have created 6 nodes here. Okay, and let me first say that node 1 is going to be connected to node 2 and node 3, and node 2 is going to be connected to node 4 and 5. Node 3 is going to be connected to node 6, and let me create one more node. Okay, don't worry if this confuse you. It's actually very easy. All right, don't worry if it is confusing you. Okay, what I'm trying to say is I'm going to have like this. Okay, let me draw it here. I'm going to have like node 1 is going to be connected to node 2 and node 3. Node 3 is going to be connected to node 4 and node 5. Node 3 is going to be connected to node 6, and node 7, right? So what I'm trying to say is the left pointer of node 2 should be pointing to n4, and right pointer of node 2 should be pointing to n5, and you can apply the same idea for n3 also, right? And for n1 also, right? That is what I'm going to do. Okay, so let me tell you how to link them. Okay, I'm going to link them manually. I'm not going to use any algorithm for it because it's not required. Okay, as I already told you, in most of the platforms you are not required to create the trees. This is just for our um, what I could say, this is just for our analysis. Okay, that's it. Okay, so let me say n1. First let me add all the data first of all. Okay, so let me fill the data fields, first of all. Okay, so n1 is going to have a value of, so how to access the data, you have to use the n1 arrow data. That's it, right? N1 arrow data. So n1 is going to have the value of 1. So let me copy this and let me paste it here. uh, all right, it's trying to create a staircase like of structure. All right, let me give proper indentation. Of course it is not a problem in C++, but it will increase the readability of the program when you give proper indentation to your program, right? It's one of the clean coding practices. All right. Okay. Let me say this is n2, this is n4, this is n3, this is n5, this is n6, and this is n7. All are not going to be 1, of course. It's going to be 2. Let me store the value 2 in the node 2. Let me store the value 3 in the node 3. It's my wish. I can store any value to it. Okay. But let me store like this. If you want, you can store your own values. Doesn't matter. Okay. 5, 6. Of course, we will try to change the values according to the algorithm so that we will be able to know whether our algorithm is working. We will be implementing a lot of algorithms, right? All right. So 1, 2, 3, 4, 5, 6, 7. Okay. Now let me link the left nodes of each tree. Okay. So n1 of left is pointing to n2 actually, and n2 of left is pointing to n4 actually. And if you have any doubts, you just I'll be in this screen for another 3 seconds. You just try to take a screenshot of it. Okay, so that you can compare it with our code. Okay, so as you can see here, n1 is pointing to n2, left of n1 is pointing to n2, left of n2 is pointing to n4, and left of n3 is pointing to n6. Okay, that is, I'm gonna code that here. Okay, so left of n3 is pointing to n6. So now I'm going to link the right nodes. Okay, n1 of right is pointing to n3, basically, if I'm not wrong. Yes, and n2 of n2 of right is pointing to, I guess it is, if I'm not wrong, it is n5. Yes, let me check. Yes, it is n5. Then n3 of right, it is pointing to n7. That's it. Cool. We have created a binary tree using this linked list approach. So we have carefully allocated space for the node. We have carefully filled the data fields, and we have carefully linked the left and right nodes. Okay. All right. One thing to note here is, here also I have to put an asterisk symbol because it's anyway it's again going to be a pointer only, right? Because if I say n1, it's just going to store the address only, right? So because malloc anyway, it's going to return address. So it's a pointer. Okay, so n1, n2, all are pointers, and they are pointing to a struct node, right? So I have to put this asterisk sign here. And if I run this code now, I hope it will work now. Right, let me check. Yes, it's working. The program is finished, so it is showing no errors. But the point here is, you won't be able to visualize the data as of now, because for that you have to traverse the tree. If you want to print all the data, you have to traverse the tree properly. So in our next set of videos, I'll tell you how to traverse the tree. Okay. After that, you can implement that, and you can traverse the whole tree. Right. Thanks a lot.